In this demo, we will perform exploratory data analysis, also known as EDA, in Databricks using Unity Catalog and SQL parameterization. We will configure the workspace setup, create widgets for dynamic query execution, and manage table structures efficiently. By the end of this demo, you will gain hands-on experience in structuring data workflows and leveraging widgets to enhance query flexibility and security. Before proceeding with this demo, please ensure that you have completed the demo on data management in Databricks Workspace, as we will use the resources created there as a prerequisite in this demo. By the end of this demo, you will be able to configure and verify Unity Catalog setup to manage data sources efficiently. Use widgets to dynamically pass variables in SQL queries for flexible data processing. Apply data transformations to filter and structure bronze, silver, and gold tables. Visualize and create dashboards to display insights from the processed data. Apply data cleanup by removing widgets and unnecessary elements in the notebook. In order to follow along, you will need a workspace with the Unity catalog enabled. In order to follow along, ensure you meet these technical requirements. You need a serverless compute cluster. Let us start this demo. Open this notebook in your Databricks workspace. Go to the correct option at the top and select the serverless compute cluster. Wait for it to get attached to your notebook. Now let's move to the first step. Run the following cell to view the predefined Unity catalog setup for this demo. This will display the catalog schema and volume details, along with their respective paths. Additionally, it defines table names that will be used throughout the workflow. These variables will be used in subsequent queries and transformations, ensuring a structured and consistent data management workflow within Databricks. Let's move to the next step. Run the following cell to verify the Unity catalog setup and display the planned table names for this demo. This will help ensure that correct catalog, schema, and volume are being used before proceeding with data processing. Let us analyze the output. We will notice that we have all the Unity catalog setup configuration along with the planned table names that we will use in this demo. Let's move to the next step. Before we proceed further, let us understand how we use widgets for SQL parameterization in Databricks. In Databricks Runtime 15.2 and above, and in the serverless compute clusters, you can use parameter markers as param to pass widgets values into SQL queries dynamically. There are three components to using widgets for SQL parameterization. The first is creating a widget in Python. To define the widget and store a variable, we use the following Python code. We first create a Python variable and assign it a value. Then we create a dbutils widgets where we assign the variable to give the same value to that widget. This widget allows the variable to be accessed dynamically in SQL queries. The second component is using widgets in SQL queries. When referencing table or column names in Databricks Runtime 15.2 and above, or in the serverless compute clusters, use the identifier function along with param syntax. Our example could be seen here is select star from identifier, and in this function we write param followed by the name of the widget my underscore table underscore name. The identifier function ensures that the widget value is treated as a valid database object name. The third and the last component is deleting widgets. To remove a specific widget, we use the commands such as dbutils.widget.remove, and in the parenthesis, we pass the name of the widget that we want to delete, surrounded by double inverted commas. To clear all the widgets in the notebook, we use another function which is dbutils.widgets.removeAll, followed by open and closed round braces. This ensures a clean notebook environment by removing unused or temporary widgets. This approach enhances security and flexibility by preventing SQL injection risks and ensure proper parsing of database object names. Please note that in this demo, we explored creating Databricks widgets in PySpark and using their values in DBSQL for parameterization within a Databricks notebook. For more details, please refer to the Databricks widgets documentation. In the documentation page, you can find all the details related to the widgets. It's available on docs.databricks.com. Now, let's go back to our notebook. Let's proceed to the next step. Before executing SQL queries, let us define widgets to dynamically pass Python variables for catalog, schema, volume, and table names. Run the below cell to perform this operation. We can notice that a widget tab has opened at the top of the notebook, and all our defined values are available here. Let us move to the next step. Run the below cell to set the newly created catalog as the default catalog. Now, any schema references will be assumed to be in this catalog unless explicitly overridden by a catalog reference. Let's move to the next step. Run the below cell to set the newly created schema as the default schema. Now, any data references will be assumed to be in the catalog and schema we created, unless explicitly overridden by a 2 or 3 level reference. Let's move to the next step. Run the below cell to query the bronze table and observe its contents. Our query has executed successfully, and we can notice in our output that our entire table is displayed here. Let's move to the next step. Run the below cell to create or replace the silver table by selecting and filtering data from the bronze table. This step ensures that only relevant records are carried forward in the data pipeline. Our code has executed successfully, which means that our silver table is created. Let's move to the next step. Run the below cell to query the silver table and observe its contents. Let us analyze the output. This is the data that we have gained from the silver table. As we can notice, it is created based on the conditions that we provided, and all the relevant column names are visible here. Let's also verify the creation of this table through the Catalog Explorer. Go to the Catalog option in the left-hand side menu on the workspace screen and right-click and open it in a new tab. Let's switch to the Catalog Explorer tab. This is our Catalog Explorer. We will notice that our catalog is listed here. Let us expand the catalog. Within the catalog, we will notice our main schema. Let us expand our schema. We will notice that there are two tables and one volumes. If we expand the volume, we will see the name of our volume. And if we expand the tables, we will see the name of all the tables created here. And our silver table is created successfully. Let's go back to our notebook. Now, let's move to the next step. Run the below cell to calculate the distinct count of O underscore order key column in the silver table. This helps determine the number of unique orders after data cleansing and transformation. Our code has executed successfully, and we can notice that the value we gained is 1 million. So basically, there are 1 million distinct orders in this table. Now, let us create a counter visualization for this output. To do so, go to the results ribbon pane and select the plus button. Then select visualization. A visualization editor dialog box will appear on your screen. In the visualization editor dialog box, you need to configure the following things. We will first start by selecting the visualization type. Let us set this to counter. Next, let us set the label as number of orders. Next, let us set the value column as count distinct O underscore order key. We can preview our visualization on the right side of the dialog box. Select the Save button to add this visualization. Now, our visualization is added to our output page. Let us rename this visualization. Go to the Results pane ribbon in the output and select the down arrow next to the tab name for this visualization. Then select Rename. Let us rename this visualization as Distinct Order Count. Now, just click outside this box to save this value. We have successfully analyzed our output as a counter visualization. Let's move to the next step. Run the below cell to retrieve the total price of all orders from the silver table. This helps in analyzing the distribution of order values and identifying high value transactions. Our code has executed successfully and our output is visible here. Let us create a histogram visualization to analyze the output. Go to the results ribbon pane and select the plus button. Then select visualization. Within the visualization editor dialog box, select the visualization type as histogram. Now in the generals tab, select the X column value as O underscore total price column and set the number of bins to 10. Next, move to the X axis tab. In this tab, name the X column as order amount. Next, move to the Y axis tab. In this tab, name the Y axis as number of orders. Preview the visualization on the right side of the dialog box. Then select the Save button to add this visualization. Now we have successfully visualized our output. Let us rename this visualization. In the Results pane ribbon, go to the drop down arrow next to the name of the visualization tab and select Rename. Let us name this visualization as Distribution of Order Amounts. Now click outside this box to save this value. Now let's move to the next step. Now let's create a gold table with the order status counts. Run the below cell to create or replace the gold table by aggregating order status counts from the silver table. This step helps in analyzing the distribution of different order statuses. Our code is executed successfully, which means our gold table is created. Let us scroll down to the next step. Run the below cell to query the gold table and observe its contents. We can notice that there are three categories of order status and their count is available here. Let us visualize this output as a pie visualization to analyze the distribution of orders based on their status, providing insights into the proportion of each order status in the dataset in this output. Go to the results pane ribbon and select the plus icon. Now select visualization. In the visualization editor dialog box, configure the following. Select the visualization type as pie. Now, within the Generals tab, set the X column as O underscore order status. Next, for the Y column, set the value column field to order status underscore count and set the aggregation function field to count value. Preview the visualization on the right side of the dialog box. Then select the Save button to add this visualization. We have successfully added the visualization. Let us rename this visualization. In the Results ribbon pane, select the down arrow next to the name of the visualization tab. Then select Rename. Let us rename this visualization to Order Status Distribution. Now click outside this box to save this value. We have successfully visualized our output as a pie chart. Let's move to the next step. Let us create a notebook dashboard in Databricks. You can create a notebook dashboard in Databricks by adding visualization or table outputs, allowing you to monitor key metrics in the structured format. Follow these steps to add visualizations to a notebook dashboard. First, you are required to execute your code or query. Now, let's scroll up to the first visualization. Once the output is displayed, go to the tab of this visualization and select the down arrow. Then select Add to Notebook Dashboard. If it's your first visualization, you need to select Add to New Notebook Dashboard option. A new tab will open with the dashboard containing the graph. Rename the dashboard by going to the right section of the dashboard and select the edit icon. Let us name this dashboard as EDA dashboard. Now click on the save icon to save the name. Our dashboard is now ready with the first visualization. Let's add the other visualizations to this dashboard. Let's go back to our notebook. Scroll down to the next visualization. Again, for this visualization, go to the results ribbon and select the down arrow next to the name of this visualization. Now select Add to Notebook Dashboard. You will notice there are two options now. One is your available dashboard that you created and other one is to add a new notebook dashboard. Since our dashboard is already created, select the name of our dashboard. Now click outside. Let's switch to the dashboard tab and observe the changes. We will notice that our dashboard is now updated with both the visualizations. Let's repeat the same for the remaining visualizations. Let's go back to our notebook. Now move to the next visualization. Again, for this visualization, go to the Results pane ribbon and select the drop down next to the name of the visualization tab. Then go to Add to Notebook Dashboard option and select the name of your dashboard. Now just click outside to save the changes. We have successfully added all the three visualizations within our dashboard. Let's head to our dashboard page and make some customizations. We will notice here that all our visualizations are added to this dashboard. You can drag and resize visualizations for a meaningful layout, and then you can present this dashboard to analyze the output. Let us drag these visualizations to organize the dashboard as per our needs. Alright, so the dashboard is now ready. Let us select the Present Dashboard option in the right section to view this dashboard in presentation mode. We will notice here that our widgets are visible below the dashboard name, followed by the actual dashboard. Select the Exit option in the top left corner to exit this view. We can explore additional customization options in the right side panel of the Dashboard tab to customize our dashboard as per our requirement. Let's go back to our notebook. Let's move to the next step. With this, we have come to the completion stage of this demo. After completing this demo, it's essential to clean up any resources created for this demo. Let us start by deleting all schemas in the default catalog. The below cell first retrieves all schemas within the target catalog using the show schemas command. It then filters out system schemas before proceeding with deleting all those schemas, ensuring that all associated tables and volumes are removed. System schemas like information underscore schema are skipped to prevent errors, and the cascade option ensures that all dependent objects are properly removed. Run this cell to perform this operation. Our code is executed successfully and our schemas are deleted. Let's move to the next step. Now, let's delete the catalog. The below cell attempts to delete the target catalog using the drop catalog command. If the catalog exists, it is removed along with all its associated schemas, tables, and volumes. Any errors encountered during the deletion process are handled gracefully. Run this cell to perform this operation. Our code is executed successfully and our catalog is now deleted. Let's move to the next step. Let us now clean up the widgets created during the demo. The following cell will clean up by deleting all the widgets that were created during this demo. It ensures that the environment is left clean with no unnecessary artifacts remaining. Run this cell to perform this operation. We will notice that our widgets pane has disappeared from the top of our notebook, which means all our widgets are deleted successfully. Let's move to the next step. Let us now clean up the CSV datasets in the working directory. If we go to the File Explorer, we will notice that as part of the demonstration, we have now created movies.csv and orders.csv within our file browser. Let us now clean up these datasets. The following cell scans the working directory and deletes all the CSV files except movies.csv. This ensures that unnecessary datasets generated during the demo are removed while preventing the required file. Any errors encountered during the cleanup process are handled appropriately. Run this cell to perform this operation. Our code has executed successfully, and we can notice that all the datasets are deleted except movies.csv. Let us verify the same by going to the file browser. We will notice here that only the movies.csv dataset remains and the orders.csv dataset is deleted. Let us minimize this now. With this, we have completed the cleanup and all the temporary resources are removed, preserving the required dataset. In this demo, we explored the key aspect of exploratory data analysis in Databricks, including Unity Catalog configuration, SQL parameterization with widgets, and structured data management. We learned how to dynamically reference tables, execute queries efficiently, and ensure secure database object handling. By applying these skills, you can streamline data exploration and improve workflow automation in Databricks. Thanks for watching. In this demo, we will perform exploratory data